my name is Ryan Lindfield, and I'm here today from Stormwind to tell you about the Cisco UCS fabric interconnects and the purpose of port personalities. The port personality is what tells the UCS what the ports are actually used for. If you take the fabric interconnect out of the box, you plug it into the rack, you've got a bunch of SFP sockets just looking at you, and well, it's up to you as the administrator to populate those ports with SFP modules that are going to be 1 gig, 10 gig, or maybe 8 gig or 4 gig for your fiber channel. After we put the right SFP adapter in there, we've got to tell the UCS what those ports are going to be used for. So the port could be an uplink going to the rest of the world, it could be a downlink going down to servers, it could be an appliance port going out to the side. We have to tell the UCS, what do you expect to see when you send traffic out of those ports? Because the way that the Fabric Interconnect works, he does certain types of things on certain types of interfaces. So let's go forwards and take a look at what the Fabric Interconnect is going to do on each type of port. Looking at our 6248 for starters, you have to understand one of the first things we're going to do is set the port type. The 6248 is called a 6248 UP, which stands for Unified Ports. They're unified because they can be used for either Ethernet or for fiber channel purposes. We first have to set that within the UCS manager. There's actually a really neat utility where you're just going to take your mouse, you're going to click on an adapter, and it's actually just a little bar. And you'll see the visual representation of the 6248. You've got 48 ports looking at you, and you say, I want these ports, and you'll use your slidey bar to take a look and say, these last 4 ports are going to be used for fiber channel. The other ports, everything to the left of that, is going to be used for Ethernet. This is setting your port type. That's the highest level of categorization that you're going to have to do as an administrator. Ethernet on the left, fiber channel on the right. You control the slidey bar for how much of Ethernet or fiber channel traffic you plan to send out of those ports. Now, take special note that the fiber channel ports are for native fiber channel, not fiber channel over Ethernet. So that'll be a fiber channel SFP. We're going to take that port and cable it over to an MDS and do fiber channel traffic directly with that end device. Fiber channel over Ethernet is where we come out of the Fabric Interconnect, we go up to a Nexus, and we're carrying the fiber channel traffic alongside of our Ethernet traffic to that next device. Now that was introduced in, I believe, 2.1. Prior to 2.1, you could only do native fiber channel out of the Fabric Interconnect. So for our purposes today, looking at the 6248 here, we see that we've got 48 ports, they're unified ports. We use a slidey bar, just like my hand here, to say these are going to be Ethernet to the left, fiber channel over to the right. Once the port type is selected, that's when we get into port personalities. What we see here in the next slide is the different port personality types for our uplink ports and our downlink ports. Sometimes if you listen to different blogs or I don't know, I like Packet Pushers, great podcast. When these guys are talking about it, they'll talk about the terms northbound and southbound quite a bit. Sometimes you'll hear people say uplinks and downlinks. So if we take a look at the actual ports here, our topology here is kind of turned on its side, but you notice that we have an uplink and a server port. The uplink is what's going to connect out to the rest of the world. Could be a Cat 6500, it could be a Nexus 7000, it could be a non-Cisco switch, but why would we want to do that? What we're going to have northbound is just Ethernet traffic, or possibly in 2.1 fiber channel over Ethernet traffic, but this is us getting from our UCS domain out to the rest of the world. Everything southbound or on a server port is where we take our Fabric Interconnect, we take our 10 gig FCOE connections, we put them into an I/O module, and that's how we establish connectivity to the blade. So the big picture you want to get your head around is, once we've told the Fabric Interconnect that these are Ethernet ports, we then say, what is it being used for? Are you talking to the rest of the world, where you're actually pretending to be just a VMware super server? You say, hey, I'm not a switch, I'm just this box that happens to represent 10,000 virtual machines that are running behind me. I'm not doing spanning tree with you. I'm not behaving like a switch. I'm just behaving as, for lack of better terms, a super server. Now on the southbound ports, we are doing things like a switch. We're running NXOS, we're learning MAC addresses, we're paying attention to VLANs, but we only appear to be doing that on those southbound ports. So what is the Fabric Interconnect? Is it a switch? Is it a controller or brain for a bunch of servers? It depends on who you ask. If you were to ask an uplink port, It appears to be a super server. If you were to look at a downlink port, well, in that case, he's a switch just providing connectivity to the rest of the network. Us setting a port personality lets the Fabric Interconnect know what types of conversations should he be having out each one of those ports. Our highest level of categorization is going to be an uplink, going to the rest of the world, or the server port, which goes down to, you guessed it, our servers or our 5108. Those aren't the only type of port personalities, however. Looking forwards, we've also have these appliance ports. Why would you do that? Well, if we wanted to connect additional devices, let's say that we wanted to take a chassis, like a half rack, and put as many devices as we could there, like direct attached storage. Maybe I've got a iSCSI storage array, or I have an NFS storage array from the vendor of your choice. I don't know, maybe NetApp. We could take that NetApp storage array, doing NFS, doing iSCSI, whatever you're using on it, and cable that directly into the Fabric Interconnect. So the Fabric Interconnect is not in his more traditional role of an uplink or a downlink, because we're not going out to the rest of the world. We're not going down to talk to a blade server. We're just going over the side to talk to some maybe, non-local storage. So it's storage that's not contained within the blade, but we don't have to go up to the Nexus 7000 to get to it. We'll say this storage here, this NetApp storage array is only being utilized by the blades in the 5108. So let's go up to our Fabric Interconnect and then just jump over to our NetApp array. Alternatively, another type of device that you may see people throwing into their Fabric Interconnect as direct attached might be the Cisco Nexus 1000V 1010. The 1010 is actually, as you may already know, a C-Series server. The C-Series server, his only job in life is to run virtual supervisor modules. These VSMs control all the VEMs within the Nexus 1000V, which super cool technology. Can't wait to talk about it later, but that's going to be coming in a future episode. For now, just looking at port personality types, we've discussed uplink, out to the rest of the world, downlink going down to the servers, and these appliance ports where we could directly attach other devices like a NetApp storage array doing iSCSI or doing NFS directly into the Fabric Interconnect, or possibly a Nexus 1010 directly into the Fabric Interconnect. So other appliances are being directly attached in. That's not all we've got though. Another type of storage port that we're going to have is going to be your FCOE storage port. Now this is pretty new, but what we have the capabilities to do is get a device such as, about 3 weeks ago, I had a student in class who had an EMC VNX, and the VNX was speaking fiber channel over Ethernet. Well, what we have the capability to do is coming in from our converged network adapter. We've got that chip on the CNA, which is talking to the host operating system, pretending that he's a real fiber channel controller, and I guess he is, right? The chip is there. But when we're making calls to that chip, saying, hey, I want to write these SCSI commands to the disk, the fiber channel chip goes, okay, no problem. He sends that forward. It hits our Ethernet NIC, which is going to encapsulate the fiber channel in an Ethernet frame, send it out through the I/O module up to our Fabric Interconnect. Fabric Interconnect can then speak FCOE to a directly attached device, like the EMC VNX. So notice we're not using fiber channel GBICs anywhere. We've got Ethernet GBICs all over, and the fiber channel is being carried from your blade to that storage array all over Ethernet. And we can do this without having an upstream Nexus switch, an upstream MDS. We're doing all of this locally on the Fabric Interconnect. Very cool stuff. Another common question that I typically get is looking at the Fabric Interconnect is doing an awful lot of things. It's at the lowest level running Linux. On top of that, you've got NXOS. On top of that, you've got the UCS manager. A lot of things happening, and they go, well, in terms of NXOS, what types of things can I do to it as a switch? To be honest, it's fairly limited. You can't do a lot of configuration. You can typically just, I go into it for show commands, for doing debugging, for looking at possibly like MAC address conflicts and things. So I'll drop into NXOS for that. When I'm describing troubleshooting, first question that comes to mind, people go, well, wait a minute. There's switching going on in there. Do I have the capability to perform switch port analysis or span? And the answer, as you can see here in my slide, absolutely. We've got the capability to do a monitoring port personality. So once again, 6248, we take it out of the box. He's got 48 ports. Our job as the administrator is to tell the Fabric Interconnect what are those ports actually going to be used for. So when we look at a monitoring port, This is a device or port that's going to connect to a device that's being used for, you guessed it, monitoring. Now, is your MacBook Pro with a 1 gig interface going to do a great job of parsing 10 gigs worth of traffic coming off of your of possibly FCOE or iSCSI storage or whatever else is going on in your Fabric Interconnect? Probably not. This is a time where you want to go to maybe a vendor like Fluke and get a dedicated appliance that can process that 10 gigs of traffic, and that's what we connect into this type of an appliance port. A good dedicated appliance that just looks at monitoring traffic, nothing else. And that's essentially what we'd use the monitoring port for. So what we've discussed today is that the Fabric Interconnect has a number of ports. Well, fixed ports, say we've got 48. Those ports can have different personalities, which allow us to instruct the Fabric Interconnect how to behave on those ports. He's not just a simple switch. He's doing a lot of complex functions. Those functions are going to be set on a port-by-port basis. Uplinks going to the rest of the world, downlink going to your 5108. You're absolutely going to have those too. I don't care what you're doing. No traffic is getting in or out of those blades without those two port types. The other port types are, I guess you could say, optional. You may have appliances that you want to directly attach. You may have fiber channel over Ethernet that you want to attach. Or ultimately, if we want to do some monitoring, we've got the capabilities to set up a monitoring port personality. So this is it for this section, but in a future section, we'll talk about fiber channel, which also has port personalities. We can say, yes, it's a fiber channel port, but it's doing these different things. Thanks for tuning in today, and I hope this was a useful session for you.